Thanks for attending our webinar, everybody, on Advanced Lithium Storage Made Simple. This is a joint webinar between Fortress Power and Morningstar. Fortress Power is one of Morningstar's energy storage partners, and we've been working with them for about 2 years now to determine and share with you the best charge controller settings and other information to optimize battery performance for your systems. My name is Mark McHenry, and I'm going to be moderating this webinar. And before we start, let me remind all attendees to type any questions that you have in the questions chat box on your GoToWebinar console, and we'll address as many of them as we can at the end as time permits. And if we can't get to your question during this webinar, we will respond by email. We are recording this broadcast, and we will email you the recording tomorrow. We've also included a copy of our slide deck in the handout section of your GoToWebinar pane that you can download right now. So with that said, let me introduce today's presenters that you see on this slide. First, from Fortress Power, we have Alex Lepore, Western Sales Manager, and from Morningstar, we have Brad Burwald, Senior Product Manager. Alex, let me hand off to you and let you start the presentation.
Very good, Mark. Thank you for the introduction. Welcome everybody to this webinar. Before I dive in here, I want to thank the Morningstar Group for hosting this webinar with us, as it seems like we always get a lot of good interest and we always are able to help people and pass along the appropriate information. So a little about who we are and what we do here at Fortress Power to start it off. So we're a lithium iron phosphate battery provider focused on residential and commercial applications. We're headquartered in Southampton, Pennsylvania, which is just northwest of the city of Philadelphia. We were founded back in 2016 and we're owned by a group of investment bankers and solar veterans. And you can see here on the right-hand side, this is our facility. It's a 30,000 square foot facility where we do a lot of the R&D, sales, and logistics. That being said, we do have 2 other warehouses, one in California and one in Florida. And we've seen a lot of interest and a lot of growth in batteries since inception back in 2016. We've seen installations not only on the continental US territory, but also in Canada, the Central Caribbean, South America, Europe, and Africa. We are the exclusive lithium battery supplier for SEPTA, which is a local railway company based right outside and in the city of Philadelphia, along with Hydro-Quebec, which is a Canadian utility company, and they're sourcing a few of our batteries for a hydro application in Canada. So very interesting, and I'll dive into more on the products that we have as well as the different applications that you can use a battery for. Next slide, please. So there's a lot of, I think, questions with, what can I use a battery for? And there's a lot of different applications that a battery can fit into with your project. So the first thing is typically backing up your facility. So per NEC code in the United States, at least, if the grid goes off, your solar stops producing. So what a battery can do is during an outage, the battery will keep your solar panels running. So meaning you can back up the electrical loads in your house while continually keeping the solar panels generating electricity and ultimately powering your home. You can also use this in self-supply. So this is where you can have solar in a battery where the grid may prohibit backfeeding to the grid or selling back to the grid. So essentially, you're maximizing your PV production because any excess electricity that's generated without a battery, and if you can't sell it back, it's lost. So adding a battery in areas where you're not allowed to sell back, or maybe that sell back is not really as healthy as it should be, that's where having a battery can help you store that excess energy and then either use it for a later date, or you can just have it, on a rainy day when the grid does go off and you have that saved up there. Another really interesting application that you can use a battery for is for a time of use, or I call it peak period shaving. So this is where in certain areas you will pay crazy amounts for electricity during certain times. So for example, let's imagine it's from 4 p.m. to 9 p.m. Instead of paying maybe 20 cents a kilowatt or 25 cents a kilowatt, you could pay anywhere from 30, 40, or even 50 cents a kilowatt. So you can use a battery with your solar to discharge during those peak periods, let's say it's 4 p.m. to 9 p.m., to offset all those high charges you would normally get during that time. So as you can see here, there are a lot of different applications to use the battery. It's not a one size fits all by any means, as every project will call for maybe a different battery size. And depending on where you're located as well, will call for maybe a certain application in favor of another. And in the United States, there is a 26% federal ITC tax that is available if it's powered by solar. And then there are a lot of different state and utility rebates. Now, this is just in the US. And so for the people joining this webinar from outside of the US, I would recommend that you reach out to your local, local states or local areas and see if they have incentives or rebates for batteries and solar, because it can certainly be something to help you grow the battery space in your own particular industry. Next slide, please. So I think that another question that I always get is why storage? Why are batteries becoming this up and coming thing? You know, if you look at batteries in the past 5 or 10 years, it was a very slow growth. A lot of early adopters had picked up batteries. Now it's entering the mainstream market. Why is this? Well, I looked at a Department of Energy analysis, and you can see here by 2030, stationary developments will exceed 150 gigawatt hours of storage. And then we're going to see 27% of annual growth for grid-related storage applications. So if you see here on this graph here on the right, the grid-related is the orange bar. You see from 2021 to the end of this decade, just grid-related storage alone is going to, it looks like 5 times over grow. So that being said, the largest market moving forward is going to be North America at 41.1 gigawatt hours, followed closely by other markets in Latin and South America, and also other European markets like in the EU or even in Eastern Europe. So if you really think about why storage, it's because of the economies of scale of many batteries all across the world. Next slide, please. And so I think it really comes down to 3 factors. The first thing is the battery affordability. So if you look at solar alone in the past 10 to 15 years, even in the past 5 years, the cost of solar has fallen over 20%. And so we're estimating that by 2029 that you're going to see a 46% price reduction in the lithium battery cells. So not only is there a growing need for batteries, let's say for emergency power, but you're also seeing a price reduction and more affordability with the solar and solar batteries, meaning that as time goes on, you'll be able to get more bang for your buck. And this is only going to get better with more incentives, my second point. So as of now in the US, there is a 26% federal ITC extension that's going to 2022. And there's a lot of statewide incentives in the US, like the SCHIP incentive, the GMP incentive, and other statewide rebate programs. Like I said earlier, for those of you not in the US, I would highly recommend you do your due diligence and find out what kind of incentives are available where you are to see if you can leverage those incentives to your benefit. And then lastly, on top of the affordability and more incentives are being released because people are seeing this growth, is this shifting mindset, this awareness of batteries are available and batteries are here. The first one is simply put, it's fear. I think batteries, especially in emergency power applications in the US, take a look at Texas, and even earlier this year, you take a look at California and those fires. People are scared, and I don't blame them. There's a lot of outages. The once in every 500-year storm is no longer the reality. Now we're seeing 2 or 3 storms a year that are these categorized as a once in a 500-year storm. So people are now shifting their mindset, instead of relying on the utility to handle everything for them, to be more independent, to invest in solar and solar batteries. There's also this higher emphasis on renewables because of what we've seen with the statistics following climate change, right? With carbon in the air and rising temperatures, rising sea levels, et cetera, et cetera. So there's definitely more emphasis on renewables and more push for renewables to be the primary point for energy production or consumption, instead of fossil fuels, excuse me. And then lastly, I think is a lot of on the political administration side, you'll see more, I think, governments like in the US, for example, are now going to be pushing more incentives and pushing more into the green side of things. So you'll see between the shifting mindset, rising incentives following that shifting mindset, and then affordability because of the battery growth and economies of scale. I think this is partly why we're seeing such drastic growth with batteries, even in the past 3 years. Next slide, please. So if we look at what we have here at Fortress Power in terms of our battery options, they range anywhere from 5 kilowatt hours and can scale all the way up to 200 kilowatt hours. So from left to right, you see here we have two of our original models, the LFP5 and the LFP10, respectively. And then in the middle, you have the EVault 18.5, and then you have the newest EFlex 5.4. We've seen a lot of very interesting projects and good feedback on the EVault 18.5. Why is this? Because first one is that the LCD display on the front, so you can see your state of charge of the battery, how many batteries you have in parallel, the voltage of the battery, and then this particular unit can stack up to 12 for 200 kilowatt hours. So that's why I mentioned anywhere from 5 to 200 is really our bread and butter in that small residential and small commercial area. Some other cool features about the EVault 18.5 is that it does come with a relay-based BMS. I'll be touching base on that later in the presentation, along with the fact that it's just easy to install. Instead of having many small batteries in parallel to get a large capacity, you can use one EVault instead of many smaller batteries. So you can I would certainly recommend the EVault for any larger projects, maybe off-grid projects or a project where they're wanting to offset their rate charges, like in time of use. And then we move over to its younger sibling over here, the EFlex 5.4. This is our newest unit, and this is a more modular approach to a similar idea with the EVault. So the EFlex can stack up to 15 for 80 kilowatt hours, and it's really neat because the aluminum enclosure is IP65 rated, so it can actually be placed indoors or outdoors. So between the EFlex and the EVault, these are certainly our two flagship products, but I certainly wouldn't want to discount the LFP5 and 10 as they have their own respective pros and cons. You can use the LFP5 and 10. The 10 can scale up to 2 for 20 kilowatt hours, and then the LFP5 can scale up to 3 for 15 kilowatt hours. So for any smaller residential projects, smaller projects where they might only need 10 or 20 kilowatt hours, then the LFP10 may be a good idea, maybe for larger projects or if they have a smaller footprint where they can actually put the battery. That's where I would see success with the EVault and the EFlex 5.4. Next slide, please. So a little bit more on the EFlex, because it is our newest unit. Like I said, it is stackable up to 80 kilowatt hours. And then the neat thing is it can be used for many of the different applications you see on the market. So not only residential energy storage like we do here at Fortress, but also commercial and industrial power backup, railway communications, telecommunication applications, military, and off-grid. Some other key features of the EFlex, it does have data logging and as well as a Wi-Fi app for remote monitoring. So we will have an app for the EFlex or Wi-Fi remote monitoring, which will be available around in Q2 or so, I believe is the last update I heard. And since because of its smaller form factor and its smaller size, this can be installed really anywhere. You can put this on the wall, you can put this on the floor, you can put it into a standard shelf mount solution like you see here on the bottom left, that small picture over there. So I think the key things here, it's a very smart unit because of the BMS. I'll touch base on that soon. You'll have monitoring available, and then the flexible installation, not only size-wise, but where you can actually install. Next slide, please. And I did mention I was touching base on battery management systems. So I will do a comparison later in the slideshow regarding how lithium compares with lead acid. And I think battery management systems is very, very important, especially when learning more about lithium batteries. So there's two kinds of battery management systems that are most popular, if not the most popular on the market, and it's a MOSFET-based BMS and a contactor-based BMS. So a MOSFET-based BMS is essentially a circuit board on your battery, which is going to prevent overcharging and deep discharging, overheating and low temperature protection, overcurrent protection, and has that cell monitoring and balancing feature. So in general, the MOSFET-based is going to allow you to have the battery cells protected in the event of a high surge, et cetera, et cetera. Now with our two flagship products, the EVault and EFlex, this is a contactor-based BMS, or it's also known as a relay-based BMS. So what is the difference between a MOSFET and the relay? The relay actually has an actual fuse and switch and is more mechanical versus, let's say, computerized like the MOSFET. So the contactor-based will have all the protection that the MOSFET based has, like the overcharging and overcurrent protection, the short circuit protection, the cell monitoring and balancing. But then the key feature with this is that it will have you enable the communication with different inverters like Morningstar, or communication between units in parallel, and having that remote monitoring feature. So I always recommend, before you dive into a battery, if you're looking at different batteries for different projects for your home or for your business, definitely ask about what kind of BMS are they using, because the BMS is certainly the most important part in a battery. And at Fortress, we chose the higher quality contactor-based BMS because as solar projects get larger, the inverters get bigger, having a sturdier BMS, the more robust BMS, is only going to pay off in bounds down the road. Next slide. And here are some quick technical specifications on the different products we offer here. So you'll see from left to right, the eVault, the EFlex, the LFP10, the LFP5, and then we also have a specialer LFP5 24-volt battery. Some key things here I just want to point out, won't go over each one of these individually. All our batteries are 48 volts. And you can see the stacking here of the eVault is 12, the EFlex is 15, the LFP10 is 2, and then the 5K 48 volt is 3. So depending on what size project you're using, especially in residential, you have all sorts of options to choose from, whether it's the eVault, the EFlex, or the LFP5. One last thing before I move on to the next slide is we do have a 10-year warranty for any installations in the USA, and then we have a 5-year warranty for any installations outside of the United States. We do have an extended warranty option, and I can speak to that more offline here, and more about warranty coverage with Fortress Power and things like that. Next slide. So I think now I want to hand it over to Brad with Morningstar to talk about his wonderful charge controllers.
Okay, thanks very much, Alex. We really appreciate partnering with you on this webinar, and so we both get a chance to talk about our technology and, of course, you know, the integration and the way in which our products work together. So thanks very much. So again, just to introduce myself, my name is Brad Burwald. I'm Senior Product Manager at Morningstar, and I have currently heading up the product management group and working on a lot of the technical marketing, such as why you're joining us today. So to talk a little bit about Morningstar, we have over 4 million products sold and deployed into the field since our inception, which was some time ago, as we've been doing this for a while and really focused on the off-grid market, and that was since 1993. We have distribution and have sold in over 100 countries around the world, and really are focused on mission critical applications. So this is standalone, remote off-grid, and really where uptime and quality and reliability is key. And some of the markets that are for those types of applications are residential and rural electrification. So this would be homes, as well as a lot of you know, developing energy projects in extreme remote grid locations. And one such project we did was actually for a 200,000 home project for systems for solar home systems in rural Peru. And that also included 3,000 community centers, which were a larger system capable of providing healthcare equipment and IT equipment power as well. And together that really contributed to helping over 1 million Peruvians gain access to electricity in previously you know, areas that were not touched by the grid. Commercial applications are also a large part of our business for backup and other solar off-grid applications. Industrial, including telecommunications, the oil and gas industry for measurement and SCADA systems, and also security. Mobile and marine are also another big area because RVs, caravans, boating market, traditionally been a large user of low voltage DC power, and solar naturally goes along with that. And interesting because the mobile industry has seen such a dramatic surge in the COVID era, with so many people wanting to just get out and travel and get to areas, and solar helps them to do that more independently. We think of ourselves as the charging experts with an extremely wide and diversified product line. And some of these applications that I spoke about before there are you know, addressed using a variety of controllers with specific feature sets specifically for those markets that give them unique advantages. And all of this tied together with the lowest hardware failure rate in the industry, We build the products to have a long life. We have a strong 5-year warranty to back that. And interestingly, because we've been around since '93, we've actually seen a lot of our products, in some cases, in use for multiple decades, which is something quite unique. So as I said, the charging experts is really Morningstar's moniker, and I'm going to talk a little bit about some of the product line here so you can see the diversity of models that make up our product families. So everything is divided essentially into 2 categories. These would be PWM solar charge controllers or MPPT controllers. And really the MPPTs have different capabilities and a little bit of a newer design, but both of them are a mainstay of our products and really still in strong use today, because depending on the application, either product charge engine can get the job done for you. It just depends a lot on your choice of solar module and configuration and what you're really trying to get out of the system. And here you can see a broader selection of our products, both PWM, PPT. We also have a small inverter line made up of our SureSign products, those of which have also been used in rural electrification, and they're also a mainstay of a lot of industrial applications because it is a extremely small, compact, fanless inverter product that gives a steady 300-watt pure sine wave output. And also all the products featured on this page are uniquely qualified to work with our Ethernet meter bus adapter. And that product is where we are focusing a lot of effort on, because data connectivity is a big part of off-grid systems now, with the low-cost wiring and wireless communication abilities of the industry, being able to get connectivity in some cases even with satellite and remote locations. Data access is really a part of many of the conversations we're having with off-grid solar products, and all the products featured on this screen using the EMC are SNMP compatible. Okay, so you'll see that the SNMP is enabled through that meter bus converter, and all the products that have COM ports can gain that ability. And you can see that in many other presentations Morningstar has been and will be giving in the near future. We think of the solar charge controller as the heart and brain of the solar electric system. It's really the area where all of the power is flowing into, of course, the battery from the array, and also out of the battery into the load. And all of that energy is passing through the controller where it can be monitored and measured. Its job really is to convert the PV panel voltages to the proper output, which could be a simple task or a more sophisticated one depending on the voltages. It prevents overcharging of the battery. It gives the right settings in order to properly charge the battery through programming of the meter or through a PC, and we'll be talking a little bit more about that later. And it's really critical that the right product is chosen for the application and for the battery type, because the wrong choice can quickly cause battery problems or even damage the battery. And that's why Morningstar works closely with partners such as Fortress to get a lot of that integration and detail worked out ahead of time so that customers can know which product will work best for their application. And in a lot of cases, you'll have either DC loads on the battery directly, or if using our inverter, you can power AC loads as well, including lights, computers, and other types of equipment. So we have a variety of applications that we can all support off-grid. In this case, you'll see a difference in the applications for a lot of our industrial and telecommunications focused applications will more likely be native DC powered. So those would be 12, 24, and 48 volt DC loads where we're powering them directly. There's no need to convert to AC. And that is more and more common, in all of the applications that I described previously. So Morningstar is the leader in both of these solar controller technologies. Also would want to cover a little bit about why you would choose one product versus the other. All of the products deliver longer battery life, better battery charging, and of course want to get the most power out of the PV module. Generally, that is done with either the MPPT algorithm for maximum power point tracking or PWM, which is a simpler but similarly effective pulse width modulation control. And what those technologies both do is they manage the PV array, they provide charging stages, and in many cases as many as 3 or 4 stages for the battery, and also in the case of MPPT, they'll provide maximum harvest of the PPT input circuit by tracking the IV curve. And that is so that we can optimize the operation of the panel and actually convert that power from a higher PV voltage down to a lower battery voltage. And our TrackStar technology is what is the sweeping and tracking algorithm used in all of Morningstar's MPPT controllers. And you'll find that it's extremely fast. I know not everyone gets a chance to get an oscilloscope and actually look at what's happening, but you'll see that many times in a fraction of a second, we can do a sweep of the array. We can find the most efficient operating point, which sometimes can vary depending on the site and the panel and the location and the level of sun. And we'll be able to convert that higher input voltage to battery voltage. And in doing so with an extremely efficient conversion process. As I mentioned, many of our products are fanless, and the reason is because their efficiency is so high, their cooling needs are greatly minimized. And that equals a lot more delivered usable energy into the battery. So every day at Morningstar, we talk to customers. I work closely with a products team, with the sales team, the applications team, and of course, tech support, also a critical team that works at Morningstar in order to solve customer problems. And we speak with a lot of customers about the use of different types of batteries, and more notably, greater amounts describing lithium. So as we get these inquiries, and what we want to do is we want to make sure that we give the customers confidence in the choices, feedback on their questions, and of course, many times pre-vetted settings where our teams have worked with our partners such as Fortress in order to get the most efficient and correct and accurate settings in place so that they can be put into our controllers for reliable battery charging. Okay, and the Energy Storage Partner Program is what frames all of this work with the various partners that we have in the industry. And what we do is we, as I said, talk with them, their technical teams, and we consolidate a lot of the feedback into an agreed upon set of programmable settings, or in many cases, just a preset file that can be loaded easily into our charge controllers. And this makes sure that we're consistently providing the best experience in managing that battery. It really simplifies installation. It makes it a lot less complex because the settings can be loaded as a single file and you don't have to dig into all the details. And the users will have confidence and also strong documentation from our website that they can rely on for those battery choices. So, and Fortress is, of course, having the many models. We've worked together with them several times in documenting their ongoing new product releases so that we've got this information on our website. Okay, so that's a little bit of an overview of Morningstar and our products and technology. So with that, I'm actually going to hand the presentation back to Alex so he can go into further detail on Fortress's products.
Thank you, Brad. Thank you. So in this battery technology comparison, the purpose that we are doing this is because there's a lot of questions on not only lithium batteries in general and the different types of lithium batteries, but lithium versus lead acid and all those different kinds of approaches that people take when wanting to store their energy. Next slide, please. So there are three popular lithium chemistries on the market, including lithium iron phosphate, which is the chemistry that Fortress Power uses, lithium ion or nickel manganese cobalt, which is something similar to what a Tesla uses or LG Chem, and then there's a lithium polymer, which is similar to what is the battery in your phone, for example. So the reason why we chose a lithium iron phosphate boils down to three main reasons. The first is the safety. So the lithium iron phosphate chemistry is hands down one of the safest lithium chemistries, if not the safest lithium chemistry on the market. I'm sure we've all seen the footage of lithium ion or the nickel magnesium cobalt batteries experiencing that thermal runaway. So the first thing was the safety of the lithium iron phosphate is the gold standard for batteries, especially with a battery that's going to be in or near someone's home. That's especially why we chose to go with the lithium iron phosphate chemistry. The second thing is the eco-friendliness. So you can actually recycle lithium iron phosphate much easier than you can with a lithium cobalt or lithium polymer. Now, why is this? From what I've understood, this is because of the added element of cobalt in a lithium ion or NMC battery that makes it much not only harder to recycle, but a lot more expensive. So not only is it eco-friendly and safe, but the thermal stability plays into all three. So you don't have to worry about any chance of thermal runaway with lithium iron phosphate because of the safety of its chemistry. Now, if we look at the life cycles, we have a 6,000 life cycle guarantee here at Fortress Power. The NMC chemistry has around like 3,000, they're 3,500, and then the lithium polymer has around 1,500. So between the life cycles and the safety, This is why we chose the LFP chemistry. And I have a really nice chart in the next few slides that breaks down each different chemistry and then other features and different pros and cons moving forward. One last thing is the energy density of LiFePO is actually less than the NMC. So although, like for Tesla, for example, their car series, like the Model S or the Model X, it certainly makes sense for them to use an NMC battery in their car line because they need a very dense battery to move that car from point A to point B. Now, in the case of home energy storage, where you want the safety, you want the thermal stability, and the long life cycles, that's why I've seen a lot of people now considering the lithium iron phosphate version because of those few different things. So I think for home energy storage, phosphate's the way to go. But that being said, NMC or lithium polymer have their own respective pros and cons, whether it's an EV or whether it's in your phone. Next slide, please. So one thing I like to show is if you guys head over to YouTube and type in LFP versus NMC safety test or nail test video, it's a very interesting video where they take a 10-penny-inch nail and drill it through the center of both kinds of cells. So you see here on the left-hand side, we have an LFP cell, drilling the nail right through the center, and you'll see throughout the video, there is some minor smoking that takes place, but you can see here, it's gonna go right through, it comes out, you're good to go. If you look over here on the right-hand side, however, this is the same test with a 10-penny-inch nail with a nickel magnesium cobalt technology or cobalt cell, and it goes full-on apocalyptic, bursts into flames, the whole 9 yards. So the purpose of this is that if you have questions or people have questions on, why is this, show them this video. And I think this video is a great illustration of you can drill a nail right through the lithium cell or a lithium iron phosphate cell, excuse me, with no, granted, I'm not going to recommend that, but you could do it and there would only be some light smoking in comparison to the right-hand side over here. Next slide, please. So when we look at why lithium, I think it boils down to maybe 8 or 10 key facts. The first thing is the long lifespan. I mentioned 6,000 cycles versus 3,000 cycles versus 1,500 cycles, and then the low energy cost in the long term. So although with lithium iron phosphate, you may pay a little bit more upfront because of the longevity and the high cycle life, you're actually paying less per kilowatt hour versus another option or even a lead acid option. Has a very high round trip efficiency at 98%, and it's very compact and more lightweight than a lead acid battery or another lithium battery. Another cool thing with lithium is that there is no ventilation needed. In standard lead systems, like a flooded lead acid, there is a need for ventilation. There is no ventilation with lithium, and there is no maintenance either. So you don't have to go back and fill up the water or, kind of take part on those mundane tasks with lithium you install, and then you're done. The other cool feature is it can do 100% depth of discharge and has the ability for fast charging and discharging, and it also has a more consistent discharge power. Now, why do I say consistent discharge power? Well, if you folks can look at my second graph here on the bottom left, you'll see on the bottom, this is amperage, and then on the top, this is capacity. So you'll see here we have an LFP as the green line, you have a flooded lead acid, an AGM, and a gel battery. So the purpose of this is showing that as your amperage increases, aka you're pushing more load out of the battery to the electrical loads, to X, Y, and Z, your capacity is going to stay the same. You're not going to lose any capacity as you increase your amperage. Now let's take, for example, the red line, flooded lead acid. Your capacity starts off very high, but as soon as you start pushing out current, your capacity drops rapidly. So what does this mean? This means that when you're sizing a battery, specifically a lead acid battery, and you're knowing that you're going to have to push out 50 amps at one point for an electrical load, you're actually going to have to size it much larger because of that capacity drop as your amperage increases. So, for example, if you had a need for a 200 amp hour battery bank, lead acid, you would have to get a 400 amp hour battery bank because of the drop in capacity and that you can only discharge at 50%. In comparison with lithium, you could get a 200 amp hour lithium battery because of the 100% depth of discharge, and then you're good to go. So there's no need for oversizing to compensate because of that main chemistry difference. Next slide, please. And then if we look at the space comparison of LFP versus a AGM battery, you can see here on this picture, we have the Fortress eVault, the 18.5, beautiful unit. And then you have here some AGM batteries. Now, even this is 250 amp hours of battery bank versus 360 amp hours. So this eVault is less than double the size of this bank here on the left, but has 110 more amp hours of capacity. Wow. So really, LFP in comparison to lead acid, not only is it a third the size and a third of the weight, but you can use it more. There's no maintenance. There's a lot of benefits to switching over to lithium, especially from the traditional lead acid approach. Next slide, please. So if we look at a comparison of all the different battery technologies out there, we have a good old LFP over here on the left-hand side, lithium ion, or that nickel manganese cobalt, lithium polymer was that battery in your phone, the flooded lead acid, AGM, and then nickel iron. Two things I want to basically showcase here on this comparison is this idea of energy throughput. Energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifetime. So for example, we look at LFP, you can expect to store and deliver 47 megawatt hours throughout the lifetime of this battery. If we look at some other batteries out there, lithium ion is only at 22 if we're rounding up, flooded lead acid is only at 2 if we're rounding up, and the only one that even comes close is a nickel iron at 41.6. But heck, I mean, look at the cost of a 10 kilowatt hour battery. You're paying 2, if not 3 times more for a nickel iron for a comparable energy throughput in megawatt hours. So I mentioned how the cost per kilowatt hour, because of the long life cycles and the chemistry itself, you'll see the cost per kilowatt hour of LFP is less than double that of the lithium ion. And then certainly compared to polymer, flooded lead acid, and AGM, there really is no comparison to be made. The only one that's probably close is the nickel iron at 19 cents a kilowatt hour. And obviously the safety of the LFP is something that's very important, especially if the battery is in or around your home. And then there is no maintenance like in a flooded lead acid or in a nickel iron battery. So when you're choosing your battery, keep a lot of these things in mind, because LFP is certainly a good choice, but I always say not one battery can fulfill all the different battery applications out there. There's all sorts of projects, there's all sorts of ways that things can be done. So keep that in mind. LFP may certainly make sense in one application, but it might not another application where an AGM could take its stead. So keep that in mind as you look at different battery technologies outside of just lead acid versus lithium, because there are subcategories in that as well. Next slide. So before you choose, there are 7 lithium characteristics that definitely affect your system behavior. I won't dive into this too much for the sake of time, but the first thing is that battery management system. I mentioned the MOSFET-based BMS versus the relay-based BMS is the most important thing. The second thing is the narrow voltage range. So there's less fluctuation or traveling between the low and the high state of charge. Cold temperature charging. Lithium is not particularly fond of cold temperatures, so I would always recommend that if you are in an environment where you're installing lithium in cold, you might want to throttle back the charging and or discharging in those temperatures. For more questions on temperature ranges, just throw them in the chat and I'm certainly glad to address them. The full discharging of the battery, we recommend an 80% depth of discharge versus 100% depth of discharge, which means of how much of the battery you're using, 80% of that battery versus 100% of that battery, the low self-discharge, and then the high charge or discharge rate. So meaning that depending on how the battery self-discharges when it's low, or how you're charging or discharging the battery in that C rate, that's going to affect how long your lithium battery is going to last. And then the last thing is the higher upfront cost. So like I mentioned before, although lithium iron phosphate may have a higher upfront cost, you're also getting more bang for your buck. It's like when you purchase a car. You have the car that gets you from A to B, but then you have the car that gets you from A to B, but you have air conditioning. So although the higher upfront cost, you're really investing in a higher quality battery that's going to last longer. And with power being more important than it's ever been, especially in modern society, that's why we're seeing lithium really take center stage. Next slide. And then Brad, I'll pass it back to you.
Yep, thanks very much, Alex. Yeah, so it's great to hear about a lot of those features just on the last slide there, and talking about the characteristics of lithium. So we heard about the economics and the technology and the chemistry, but when you get into the details of the charge controller, this is where we'd like to take some time to look at a few of the specific things that we do with the charging technology to make sure that it's an excellent fit for this chemistry. So as Alex had mentioned, low temperature charging. There is a great amount of capabilities of these batteries, and they can work in a very wide temperature range. But in extreme cold, you do have to be a little bit careful just regarding, the charging and discharging. And generally, they meet most, if not all, applications quite well. But if you do need to make some changes to the charging profile, lithium fallback is one thing that can be done. In home applications, this is really not an issue. But in industrial applications, occasionally if you dip below freezing, what the controller can do is during that time, it can actually reduce linearly the amount of charge current so that the battery does not see excessively high charge rates in those cold temperatures. And when the battery warms back up again and cycles throughout the day, it will actually increase back. And you can see that actually shown in some later screens. The other thing is interactive meter display options. On a lot of our products with built-in meter displays, you can of course tweak settings as needed on a per value basis just by using the navigational display. So while we give you presets for a lot of these battery models, specific to the ones that Alex showed us earlier, such as the eVault, you can actually go in and even tweak those further if you want right in the field at the site. Certain batteries also can look at a signal from an RTS, and they can actually see temperature, and they can sometimes give feedback to the batteries when you want to disable charging based on low temperatures by communicating directly to the BMS. This varies across products, but it is something that can be enabled on many of Morningstar's charge controllers. These settings are easily programmable via USB. So when you connect it to a PC and load these settings, the entire charge profile, including temperature, voltage, compensation, high and low voltage disconnect, all these settings can be deployed in one quick, easy configuration file. Another feature that is a bit unique to Morningstar and really comes in handy because of what Alex had said about the more narrow voltage range. What we mean by that is, lead acid has a lot of travel, anywhere from, the low 11s all the way up to sometimes into the 15s in terms of voltage on a 12-volt system. And of course, in 24 and 48 respectively when multiplied. But what voltage sense does is it gives our products the ability to get a very accurate voltage sense, so that when those small minor changes in battery voltage that impact state of charge and system functionality take place in the battery, that the controller has really good visibility and measurement of that voltage. And how we do this is we accomplish this with a secondary sense line that's connected to the battery posts, and those wires actually go around a lot of the bus bars and breakers and disconnect and interconnection hardware that over time can introduce voltage drops. So we get a really clear picture of what exactly the voltage is right at the battery posts, and that brings across much better charging accuracy. So here's the example I mentioned earlier in the ProStar MPPT. When we enable low temperature current reduction, what you'll see is we actually program in the low voltage, the low temperature range and the higher temperature range, and across that point, you can see there in the orange, the current will actually be reduced. And you'll see that the battery does not want to see an amperage greater than what is actually in that blue graph there. And the orange graph below it is the ProStar actually keeping the current level below and linearly derating that so that it is always kept beneath the max current rate that the battery wants to see at a given temperature. Okay, you don't want those lines to cross, I guess is essentially what I'm saying, and the ProStar will keep that from happening by having that type of programmability. Okay, next, advanced custom charge settings. These are special use cases where you may need additional functionality. And what we'll do here is we will give you the ability to put in these extra protections in the system in order to prevent, any problems. And in industrial applications, this can be very useful. One is high voltage disconnect, protecting the load from damage due to high battery. If you've got a excessively charged battery, possibly from something else charging the system higher than it should be, the controller will protect the load by disconnecting. This is rare, but it's very useful because unfortunately Morningstar is sometimes not always the single charge source in the system, but it will do a good job monitoring that and protecting. Max regulation voltage will actually put a cap on a ceiling of voltage so that we'll never exceed a certain limit. This is helpful for when you have sensitive loads that do not want to see a voltage exceeded. For instance, a more sensitive telecommunications load, or in the lower voltage range, something that doesn't want to see, anything outside of, say, 10 to 15 volts, which is a really common window. So we can help to assist there. Absorption extension is the ability to provide an extended, longer charge for more current into the battery following a very deep cycle period. So if the battery went into an extended deep discharge, we can actually get a little more time into that absorption in order to help it to recover. And then lastly, we do have the ability to provide temperature compensation changes. In the case of lithium, temperature compensation is actually disabled because they want a consistent voltage applied across the terminals. But in a lot of other chemistries, for instance, nickel cadmium, has a completely different charge profile and temperature compensation from lead acid and of course from lithium. So we allow all of that to be programmed. So just a few quick comments on another type of a set of terminology that's often discussed is what we call open loop versus closed loop in terms of charging. And all of the current ESP partners and the way we work with these batteries, we use an open loop communications, which means we are charging them similar to how we will charge any other type of battery, with voltage and current sensing actually taking place across the terminals or the posts of the battery. And we will make changes in the charge profile to accommodate that, but we're really just seeing voltage from the battery directly. Closed loop is often a more sophisticated level of integration, and that's where there is communication digitally, sometimes using certain protocols with the battery BMS directly, and provides a little more integration. The current can sometimes be pushed a little bit harder because the battery is in communication with the charging system and can let it know when to hold back or when to go full throttle. And also SOC measurement can be more easily communicated. And Morningstar is doing a lot of development work currently with a lot of closed loop options, including with Fortress. So we'll be seeing more of that in the near future. So one of the things I'd like to take a step through really quickly here is just how these settings that we've talked about during this presentation can easily be deployed to Morningstar's charge controllers. So I'll go through this a little bit briskly because it's more of just a simple walkthrough. And this can of course be viewed after the fact. And if you look at the ESP partner webpage on Morningstar's website, you will see that all of these choices can be easily selected, and you can download all the configuration files and documentation in an easy to read PDF format. Okay, so by navigating to our site, you would of course choose, in this case, the Fortress battery. Our MSView configuration software is a simple PC-based utility that will run easily on a Windows machine and allow you to open that configuration file and quickly deploy it to any of Morningstar's charge controllers. And interestingly, all the products I talked about earlier that support SNMP also support the ability to be programmed because they have that common data interface. And for those listening, we actually use a Modbus interface, which is also a very common control protocol in the solar industry. So when you get the MSView configuration files for the Fortress battery, in this case, they're downloaded, they're extracted from the zip file and deployed to your PC, and you have them ready to go. And MSView can also be obtained from our website easily and at no cost. And MSView is just a couple megs in size. It's a quick and stable utility that we've used for many years, supporting customers that want to interface with our products. And you can connect to a device on your USB or even IP-based network if the product supports Ethernet. And when you connect to that charge controller, one of many if you wish, you can then establish a connection and link to that with the software, and then you can use the configuration wizard for that given product to open up and look at all the setting changes that you can make for that controller. And once you have that open, if you're welcome to browse or navigate the settings through the wizard, which will guide you through the steps. But since we already know exactly what our end goal here is, you can open that file that you just downloaded for Fortress, and in this case, load all those configurations extremely quickly and easily with no room for human error. And then you can program those settings into the charge controller. And by programming that, it takes just a couple seconds, and then those will reside as a new custom set point in the charge controller, and they will remain in flash memory, which means at that point they're basically permanent And well, I should say they can be overwritten at any time, but what I'm saying is they are non-volatile and they will not degrade or disappear during power failures, controller resets, or redeployments of the system, because most of our products are expected to be in the field for many years. So in summary, the choice of battery technology depends on a lot of factors. We heard a lot of information from Alex on their product line. Really, it's the lifetime. We're always thinking long-term here at Morningstar because of, if you've ever deployed a site at the top of a mountain and there was a helicopter rental involved, it's something that you want to plan for the long term. And you don't want to be revisiting nearly as frequently as a lot of systems may need to be. So we make that really important choice by looking at the lifespan, the maintenance requirements, or in some cases, the lack of maintenance requirements, which are a huge advantage. And of course, space in terms of the volume, again, discussed earlier, and of course, your budget. But you want to look at that total cost of ownership. And regardless of what technology it is, proper charging is really the emphasis that Morningstar is trying to make here, and we support a lot of different variations of product in the market. And with that, that concludes the presentation. So we're at the end here, and I will, of course, invite Alex back, and we will get some assistance from Mark McHenry, our moderator. If he would like to propose some questions to us, we will be happy to answer them. And if we don't get to your questions, we will try to address them offline as well, but we can hopefully take a few good ones here today. Mark?
Okay, terrific, Brad and Alex. Thank you very much. I've taken myself off mute, and we have a nice conversation between some dogs in the neighborhood here, so hopefully they won't be too loud for you here. But we do have a lot of great questions that came in. Let me just read one of them here that says, I guess there's a couple questions came in about charging secondhand lithium electronic vehicle packs, and so that's kind of outside the scope of this webinar. I know that there's a gentleman that has a support case in with us about that, so that's something. Those type of questions I think are outside of the scope of this webinar, so we're going to have to take them offline. So just to let people know about that. Boy, a lot of questions coming in fast and furious here. There's a couple of questions that touched upon safety. So if Alex could just give a quick review of that, the lithium iron phosphate safety versus other lithium ion batteries.
Yeah, for sure. So I think the main difference, like I had shown you guys in the slideshow, was the iron phosphate versus the cobalt. The main reason why we're seeing phosphate as a much safer option, less likelihood of thermal runaway, is because it does not have that added element of cobalt. Now, granted, I'm not a chemistry professor by any means, but I have heard and I've learned through my time that cobalt is particularly in some instances, can be subject to thermal runaway. So that's why you've seen with Tesla or LG Chem that they use and have had those cases. Now, why would Tesla want to use a NMC chemistry or that cobalt chemistry? Because it may make sense for their electric vehicles, their cars, because they need a lot of very small space to move that car from A to B. But with phosphate, on the other hand, since it's less energy dense, that's where we see for home energy storage, phosphate has more advantages because it can cycle a lot longer and it's obviously a lot more safer. Just like on that video I showed on YouTube with the LFP versus NMC nail test. So there's a lot of videos like that showcasing the safety of different chemistries through different tests. And I think time and time again, the tests are showing that lithium is the gold standard. Or sorry, lithium iron is the gold standard.
Gotcha. Okay. Well put. Question here: what is the warranty on Fortress batteries in Puerto Rico?
Puerto Rico, I believe it's a 10-year warranty. However, I would want you to confirm with one of my Latin America sales representatives. Being a U.S. territory, I believe it's 10 years, but I want to get you over to the regional manager there so he can confirm that for you.
Okay, very good. There's a number of questions about charging lithium batteries in cold temperatures. Roughly what type of cold temperature ranges are we talking about here?
Yeah. It's a really good question. And so I know at Fortress, we recommend anywhere from 32 degrees Fahrenheit to 113 degrees Fahrenheit is really where you want it to be as a whole. Now, granted, if you do get into some lower temperatures, if you're in the north, I know in Canada, or even in the northern parts of the States, it gets pretty darn cold. So I'd recommend if you are in those colder temperatures and you're expecting it to get cold more often than not, then I would recommend looking at something like having a space heater in with the battery, or maybe some portable heat strips you can put on. There are certainly options out there if you're in a cold environment to keep your battery running. You just want to discuss that with myself or someone from my team to see if it can be made. Now, granted, if you do have a battery and it does get cold once in a while below that 32-degree Fahrenheit temperature, that's not going to, quote unquote, ruin the battery, let's say. You know what I mean? It's not going to have terrible effects if it gets to 29 degrees, a dozen times over the course of the year. I'm more speaking to consistently cold temperatures will affect the battery as a whole over, 10 years like we have in our warranty.
Okay, very good. We have some questions here about people wondering how they can get their NABCEP CE credits from attending this webinar. So as long as you did attend, we will email you that certification. So you'll get that within a few days.
Hey, Mark, I
yes.
want to mention there's just a couple questions I just caught here that were really relevant. If you don't mind, I'll grab
Sure.
those real quick now that I got a chance to look over the list. One question was, we demonstrated the lithium foldback ability for the charge current in low temperatures. And we had a really good question is, when is that feature going to be available for the TriStar MPPT? And the answer is that product does not have that feature right now. But the reason I want to bring that up is because it is important, because that is a larger controller, a little bit earlier model, and we are integrating that feature as well as many others, including even some closed loop communication options with a variety of standards on the market in an upcoming model for that product. Okay, so we are working on that and it will be available, but you will see that the lithium foldback and current reduction is something that is available on the ProStar MPPT and PWM. The second thing that did come up is, since I did touch on SNMP, I know this is a little bit of a different nature of topic, but there were some good questions on that. And I just wanted to, if I can make a pitch for Morningstar again here really quickly, if you are looking to do SNMP polling, meaning request data from the controller, not just use the trap notifications, but get SNMP data, there is actually going to be a webinar on that tomorrow. So if anyone else who tuned in here today would be interested in that, I would invite you to check back, because that will probably answer all of your questions on that topic. And SNMP polling is available for all of our products now more recently. Okay, thanks, Mark. Those were just two I wanted to grab really quick.
Yeah, and while you mentioned that, a couple of questions came in about charging Fortress's 48-volt batteries. So you would want to use our TriStar PWM or our TriStar MPPT controllers for that.
Mm-hmm.
Some people had a question that they said, can you charge 48-volt batteries? So absolutely yes. Those would be with one of our TriStar controllers. Okay, let's see. How would Fortress lithium battery perform in areas with 100% humidity with condensation?
It's a good question. There's a lot of places, like in the islands or in Latin America, South America, where that is a reality. And what I would recommend there is we take a look at the EFlex. I mentioned that enclosure is IP65 rated, so it does a very good job in terms of resistance against moisture and humidity in those kinds of areas. If, for example, you are looking at the EVA on one of those areas, there are a lot of different enclosure companies that can make a NEMA 3R rated enclosure or a similarly rated enclosure to protect it against high humidity or salt or moisture in those kind of environments. So there's a lot of creative ways. If it's with the EFlex, it's pretty much there with the enclosure, but the eVault, we may just want to take a look at some other enclosure options, just to rather be safe than sorry.
Okay, very good. Question, can you talk a little bit about recycling and disposal afterlife?
Yeah, absolutely. So Fortress Power, I know with the phosphate chemistry, like I mentioned, can be recycled. There is a company called Battery Recyclers of America. And what they do is they have 3 EPA treated facilities, at least in the United States, where you can safely recycle the battery. So what they'll do is, let's say after the 10 years is up with your EVol battery, you would contact the Battery Recyclers of America. They would come pick up that battery and then take it to a recyclable plant where they recycle everything from the lithium cells to the aluminum on the casing to even, parts of the copper for wiring and things like that. So the company I've referred and I've talked with and worked with is Battery Recyclers of America.
Okay, very good. Question here from Carrie. With the lithium foldback, I guess this is for Brad. With the lithium foldback feature, would it be possible to leave a system connected when not being used off-season without damage to the battery system?
Yeah, I mean, one of the facts that, I mean, if you program the lithium setting, for low temperature feedback, it will, of course, limit charging. It will still provide some charging, but it can be set to be proportional to the amount that the battery can take. And that really varies depending on the battery manufacturer. And that's something we could maybe check offline with Alex to see exactly what that curve would look like, because it doesn't have to be an all or nothing proposition of on off. It can actually derate. In terms of an off-season use, that definitely would also be a good application for lithium, because it's really not too affected by being at a partial state of charge. It's perfectly happy to sit there. We want to make sure with lead acid in a remote cabin that's unattended that we're always giving it a proper absorption or flow charge, because we've got to keep it happy and healthy during that time that it is not in use. But with lithium, I know they can sit for extended periods of time. In fact, some prefer that to not be at 100% state of charge for long periods. So they would be an excellent choice there.
Yeah, and
Okay,
to kind of piggyback on what Brad said, sorry, Mark. Typically, especially with batteries, you wouldn't want your battery to sit and stay stagnant for even more than 6 or 8 months. And I always recommend, if you do foresee yourself having the battery sit somewhere for longer than that time, just cycle it one time throughout that period. Being electrolytes, and you have to remember it's a fluid in there, you want to make sure that you're cycling it so the chemical reaction is going to get you the life cycles and the lifespan that, obviously we guarantee here at Fortress. So very good question, very good point in terms of, how long can I let this sit here?
Okay, great. And does Fortress offer a 12-volt battery?
We do not. We just have the 48-volt solutions as our main line, and then I did mention we have that 24-volt battery for special projects or custom projects should the need arise.
Okay, so 48 volts and 24 volts for special projects. Gotcha. Okay. Let's see. Here's a question. What is the recharge voltage to reach full state of charge?
The recharge voltage.
I guess that would be for Alex. I know you were talking about your products, and I'm guessing this might have had to do with the display. Maybe it's something we should take offline, but that's as they're asking it, the exact words they're saying is, what is the recharge voltage to reach full state of charge?
Yeah.
Maybe that's for Brad too. I don't know. Either one of you might be able to.
Yeah, I would have to look. I mean, we have different settings. There's specifically, let's see, in the case of 48 volt configuration, I would just have to check. But what we could do is we could answer that offline, and I can in fact get the exact setting profile for the models that we support with Fortress, and we could definitely send it to that user that had tuned in today.
Okay, very good.
I want to give the right answer rather than try to get it from memory. We'll actually check on that specifically. So.
Right. Okay. There's a number of questions about using lithium batteries in cold temperatures, and what might somebody do who, they want to use lithium, but they're worried about cold temperatures as far as keeping them in some type of an enclosure, or what do people do in cold climates like Canada, for example, Alaska?
Yeah, it's a great question, especially since cold, affects lithium batteries more than not. I've seen all sorts of things. I think we have to remember that the inverter, if it's near the battery, is going to keep the ambient temperature of the enclosure or shed, room, etc., somewhat warm. Now, if it's getting super cold because you're in the north of Canada, then I could recommend a heat strip application, which is a strip that would go on the battery to keep the battery nominally above that threshold I mentioned earlier, 32 to 113. Or on another note, you get a small space heater and you can trickle charge a small space heater in that same room. So that way, if it does get cold, then you flip on your space heater and you're keeping that in that temperature range. Let's say we're assuming here that the battery and the inverter are all in the same area. So seeing things like that, heat strips, space heaters, and if it's an indoor battery, like most of them are, unless it's outdoor, then it should be inside somewhere like in an attic, a basement, a laundry room, a utility room in a house. And hopefully your house isn't getting below 32 degrees Fahrenheit. So yeah, I would recommend those few things, at least to get started.
Okay, and Grant's asking a question, how do you determine the temperature of the batteries? Is it the temperature of the casing, the ambient, or its internal temperature?
That's a great question. The internal temperature. So we're really focusing on the temperature of the cells themselves because the BMS is going to basically get all that information. I mentioned it prevents against overheating and over discharging. So it's the internal temperature of the cells. So that way, if it does get above or below that, the BMS knows this is not in our temperature range. So great question. The simple answer is it's internal.
Okay, and Maria is asking, does Fortress have distributors in Europe?
I believe we do. Oh boy, I cover the western side of the United States. I know we are working with a few partners. I'm just not sure who they are, but I could certainly find out and take this offline and get you in the right direction.
Okay, sounds good. All right, and Brad might have answered this, but just in case, another question here, is S&MP polling available and open to be integrated with platforms such as Zabbix?
Yeah, that's the S&P. The question is polling available? That's spelled POLL, meaning the requesting of data. And yes, that is an option now. It had not been in the past, but was newly released not long ago. And on top of that, we are doing not just is S&P supported by Zabbix, we've done specific integrations with them as a software partner, and we'll be covering that in detail in a presentation tomorrow morning. So definitely check our website for more information.
Okay, question here. Can you give us a rough timeline for closed loop communication between Morningstar and Fortress?
Since there is some integration, I can speak to that. It's really not something I can probably give specifics on in terms of dates. I would say it's a heavy focus this year of being able to support that. And we've already been doing some testing and have, of course, Fortress's products in our lab and in our office and are working with them on, looking at the communication protocols. And I think a lot of things are happening in this area across the industry. So with that software addition being, rapidly worked on, I'm hoping to have more news available later this year, I would say, is probably the best information I can provide at this time. But I don't have anything regarding a release date.
Okay, another question now for Alex. What differentiates Fortress's lithium iron phosphate batteries from other lithium iron phosphate battery brands?
Yeah, it's a fair question. Um, I think in a nutshell, you have very scalable options that are very safe that can be used for many different applications. We do have live technical support, so if you want to call in to our technical support line, we have someone there who can help you immediately with your project, whether you're installing your first Fortress or you're just calling back to chat about some new projects. So I'd say between the products themselves and the safety and scalability and flexibility, and then the second part of the customer service that we have here at Fortress Power, that really makes us, I think, stand out versus some other providers out there.
Okay, and Andrew's asking a question, does Fortress have a battery system geared towards industrial applications, or is it more geared towards residential?
Definitely more geared towards residential. Now, there are some new developments here in 2021 that we're looking at some different markets, but I don't think there's really too much headway on that. So for now, residential.
Okay, gotcha. And let's see. Here's one for Brad. Somebody's asking a question. I heard that you can connect to Windows PC. How about an Apple computer?
At this time, we get this question occasionally, and I'll mention a couple things. MSView, our software utility, because it does use serial communications, not just USB, but a lot of industrial applications require like an RS-232 protocol, is currently for Windows machines only. I have seen several simple and often low or no cost emulator software programs for Macs that can be used as well. One of the things that I'd like to mention as well is that overall we understand the need for greater platform support and communication with the products, and for this reason MSView is legacy software that is used as a utility across the industry, but we are in general moving more towards web-based applications and mobile applications as a way of configuring software on our products. You'll see that a lot of the meters got updated so that they can be actually configured right at the product meter itself, without the need for a PC. And if you look at our EMC software and some of our upcoming product releases, you'll find that they have Ethernet as standard, and they use a web-based interface, which is agnostic of the operating system. It can run on Chrome, Safari, Firefox, any type of, even a mobile browser. So that's where we'd like to take things. We're not there as quickly as we'd like to be, but we are headed in that direction. You can definitely
All right.
email us as well for additional support if we can help you out there on some emulator questions. Okay.
All right. And Jim asked this question: can the Morningstar controller connect to the BMS of the lithium battery?
Currently, we do support a Modbus protocol, and we've done some integrations with other Modbus products, but at this time, we do not have a direct BMS link with the Fortress battery right now. But as I had alluded to earlier, that is something that's in development. And when we do this, there's when you looked at my open versus closed loop slide, we're looking for ideally, more communications and being able to get data out of the product, as well as get some direction on exactly how much current we can give it, which will add a lot of benefits. So hopefully more on that in the near future.
Okay. And Joe asked a question about comparing the safety of lithium iron phosphate with AGM batteries. Yeah, if Alex could just talk about that a little bit.
Yeah, sure. So I think when it comes to safety, I think the main thing that came to mind for me at least was the needing for ventilation of certain lead acid systems. And I think that kind of says enough. Just because if you're using a battery that needs to be ventilated, then obviously the toxins that it's releasing aren't necessarily the best for people in a home. But nonetheless, lead acid does have safe batteries. They don't have all the safety features of like a BMS, like a lithium, for example. But to that same token, since lead acids they don't have the BMS, they are relatively safe. I would say in some instances they may be safer than the cobalt chemistry, but then again, I mean, it does depend on what kind of lead acid, what the project's calling for, and then ultimately how you're setting up that battery, because there are certain things where if you incorrectly do something, then that can also lead to maybe defects or small problems down the road. So you just want to make sure that you're doing your due diligence with any battery that you choose to make sure that you don't run into problems later.
Okay. And what kind of information can you share about battery sizing information? If there's any formulas or websites, or do you just help people do that yourselves, or do your distributors do that?
Yeah, it's
How
a
would you
great
explain
question.
that?
Yeah, it's a really great question. So I have a two-part answer here. I like to recommend that for people sizing batteries, you want your battery to be double the size of the solar array as a start. Now, sizing batteries is easy but complicated all in one sentence, because with sizing batteries you have your rule of thumb of double the size of the array, but it does depend upon what application you're sizing it for. If you're sizing it for backup or for self-supply, certainly you want to make sure it's sized well enough that the person who has the battery isn't up a certain creek when they need the battery because their battery is undersized. And then to the same point, when sizing your critical load panel, you don't want to oversize your critical load panel, because then, let's say the inverter turns on and the battery turns on, it might shut down the whole energy storage system as a whole if that critical load panel or that load panel is oversized. So there are things we can provide here at Fortress Power. If you just email sales@fortresspower.com with any system specs, that's one thing that you can do. And if you want to get another set of eyes on it, there are a lot of tools out there. There's Energy Toolbase, there's Energy Sage. There's also just online tools that you can take a look at. And there's some tools on our website, fortresspower.com, that you can refer to for more sizing. Some other of our distributors also provide sizing support for those projects. So I'd say, if you were sizing up a new project and wanted a few people to look at it, you could reach out to Fortress Power directly, a Fortress Power authorized distributor, or go online, go to your friend Google and look up some different sizing tools like Energy Toolbase or Energy Sage.
Okay, very good. And another question here towards the beginning of the presentation. Let's see the question here. Jerry's asking regarding the 46% price reduction through 2029 when you showed that on the graph. Does that include the inflation rate of about 2 to 4% annually?
Oh, that is a wonderful question. I do not know. And Jerry, I pulled that. If you go to the Department of Energy, like their website, they have a report that I read over. Now, I don't think they mentioned inflation, so it actually may not include inflation, but it may include other things balancing out with inflation, like the economies of scale. That's an excellent question. I do not know. I would want to refer you back to my source, which was the Department of Energy, as they were the one that published those statistics. And I didn't see anything there when I read through it, but then again, I may have just misread something or just didn't see it.
Okay, and I know we're getting to the end of this here. We've been on quite a bit, but just a couple more questions. Is the eVault 18.5 kilowatt hours usable state of charge or total state of charge? And
that is total capacity. So it's an 18.5 kilowatt hour battery, total capacity. So let's say you get the eVault and you're setting it up for an 80% depth of discharge. What you're going to do is you're going to go into your handy dandy calculator, 18.5 times by 0.8 for 80% DOD, which gives you 14.8 kilowatt hours of usable capacity. So how I did this math in terms of stacking for 5 to 200 kilowatt hours is if you take 14.8, multiply that by 12, it gets you up to around 200 kilowatt hours.
Okay, well, thanks for that question. Thanks for the answer. And let's see, a question here. What are the rough costs for eVault 18.5 and EFlex 5.4? Is that anything you can discuss here? Is that they have to get in contact with the distributor? What's the best way to answer?
I would want you guys to get in touch with one of our authorized distributors. Head over to our Where to Buy page on our website, and you can find, depending on where you're located, different distributors based on where you're located. I would certainly recommend that because there may be other things for your project that your particular distributor can also help on, like maybe the balance of systems or any cables that you might need, and obviously the battery itself. So I would want you guys to go to the Where to Buy on our website and then get in touch with your local distributor based upon where you are.
All right, terrific. And last question here. Let's see. Is there any new interest in Texas for solar and storage? Are there any new good case studies about that or any new interest?
Well, I think overall, Texas is a complicated situation. And I think that the snowstorms down there were certainly not expected. I think more people in Texas now are seeing the effects of not having independent backup per home. Now, it would certainly make an interesting case study as Texas adapts now, because I think what we'll see is a lot of the state of Texas as a whole implementing new, whether it's safeguards or things like that, just in case the situation would happen again. I don't know. I think it's still maybe too soon to tell. But I mean, just in my opinion, that's what I could see. Just seeing, other markets like California or even, here east in Philadelphia, where, they pivot based upon things and experiences that have happened.
If I could make one comment that's interesting, given the current events, obviously there's some people going through some very difficult times right now. And I think backup is, of course, the first thing that comes to mind. But if you want to look deeper into this and something to research offline, which I'll put out there for the audience today, is not only the extended and independence of power that can be obtained, with storage like Fortress's products, but also as we move towards the future smart grid, being able to, shift energy on and off the grid based on residential users' stored energy systems is something that is going to probably help to alleviate these types of demand control issues that Texas is also encountering. And I know California, while they haven't had a perfect reputation either, has gotten pretty far in using these sort of demand response controls for the smart grid. And storage is going to be part of that no matter what. It's going to give the independence and also benefit the utilities' ability to manage, their load balancing. So we'll see some interesting things in the future.
Yeah, well said, Brad. Well said.
All right, so with that, let's go to the last slide, which is the thank you slide. I'm going to close things out here. You'll see the contact information for Fortress Power, both the phone and email address here. We'll just leave this up here for a few more seconds, so in case you need to take any of this information down, you can just go to their website or just jot the information down here for Fortress Power and also for Morningstar Corporation. All right, so with that, thank you very much, Alex and Brad, and thanks for all of you attending. We're going to close out the broadcast. Take care. We'll see you next time.
Okay. Thanks, everyone.
Thank you.